Yeah, welcome everyone. So we will update you on the latest scikit-learn features. So we are both, Guillaume, Lemaitre, and me, we are both software engineers at Probable, and we are working in the open source team, mainly on scikit-learn. So I will briefly introduce you to the outline. Yes. Now you can see it. So what are we going to talk about? So first, we will introduce you to a new feature called a metadata routing API and one of its use cases. We will talk about interoperability of input-output data, and in the end, briefly talk about the management of categorical and missing data, missing values, and what has recently changed. So starting with the metadata routing API, which is a new feature that is almost fully available in the latest release, 1.5, since in May. And let's start by defining metadata. So metadata can be any data that is applied on top of our tabular data. And thinking in terms of functions, it could be any data that is handled by a function in the data science pipeline on top of or besides from X and Y. Thinking of use cases, so you might be familiar with sample weight or groups in scikit-learn or from other libraries. And other libraries like fairlearn or XGBoost, they also implement or define other types of metadata. And of course, metadata can always be custom. So you could use it in fairnet-related issues or in your business logic and in other custom cases. So the benefit of using metadata would not be to have your model having a better score, but it would rather be to have a more realistic model to begin with. Yeah, and what is routing? So routing just means that we pass metadata between several components in a data science pipeline. And this had been lately improved by the new metadata routing API. So before it, we only had a very restricted use of sample weights and groups, and it couldn't be used in nested structures. And with the new API, now we can use groups and sample weight in nested structures, pipelines in grid search, in cross-validation, for instance. And we can also combine other objects from other libraries with our estimators and still use their metadata. And of course, we can now also use custom metadata. So we will dive into the two types of metadata that are used in scikit-learn, which is groups and sample weight. So imagine in this scenario, so this could be data from a medical study on the effectiveness of a treatment. So in this scenario, metadata, or like sample weight, for instance, could be used to rebalance or redistribute the samples, and groups, it would be used to make sure that there's no data leakage in case we want to evaluate our model in a cross-validation. So you can see that those samples belong to certain hospitals with the colorful icons at the left side. So in this case, we would assume that there's some structural biases between the hospitals. So for instance, a hospital could have some other medical devices than the other hospital, or the patients from hospital A come from another socioeconomic group than the patients from hospital B, or they might apply to different policies. So these are patterns that are part of the data, but they are not part of the target necessarily. So if we want to decouple this a bit, we can use the groups param that scikit-learn provides. So in here you see that we have encoded the groups in a special array, and this is going to be used in cross-validation so that patients or like samples from one hospital aren't used both in the training and in the validation set of a cross-validation. So because those patterns that might exist within the data between those different hospitals, we don't want to train on them. We actually only want to train on the targets. So, and in code, this would look like this. So here we have chosen the group k-fold, as a splitter. So the group k-fold uses groups for splitting the data. So we pass the splitter, the group k-fold, and our groups into a cross-validation, and then groups are taken into account by splitting, and we have a more realistic expectation of how good the model performs. All right, this works without the new API already. So now let's talk about sample weight. So sample weight can be used to draw a model's attention to a subgroup of samples that is somehow or badly distributed. So because we can have data from two different sources. So one could be from a randomized trial with very constrained conditions, and then everything should be fine from the beginning. But most likely we will have data that comes from real-world observations, and then we might expect some imbalances, or biased data. So for instance, in this medical study example, we could observe that there is, between a certain feature, it could be race, or sex or age, that this feature is somehow correlates to the fact if this patient was chosen for a certain treatment, like the new drug that we want to test at all. So in this case, we could use sample weight to counterbalance that. So, but if we would try to pass sample weight into cross-validate, such as we've seen before with the groups, we will be very dissatisfied because we get a type error. So it wasn't implemented. We would have expected, since rich.fit used on itself can deal with sample weight and take it into account, that when we would pass rich into a cross-validate and then sample weight as well, it would magically work, but unfortunately, this is not the case. Even more, we will be disappointed when we would try to use sample weights and groups in a more nested structure as here. So what are we trying here? So we want to cross-validate again, and we want to cross-validate on a grid search, and this grid search searches on rich. So as we've seen that rich.fit could potentially consume sample weight, also the scorer that we've picked, the mean squared error, could also deal with sample weight used on its own. And we know that the splitter that we use here consumes groups. So we would have hoped that it would just work, but that's not the case. So we get the same type error. And this has been fixed with the new metadata routing API. I will show you how it works. So I will switch to the next slide, and it's the same code, okay? But this time we will use the metadata routing API to actually route the metadata to where it belongs. So in order to do this, because it's still experimental, we have to enable metadata routing. So this is how we do it. We set a global configuration to enable metadata routing, and that's it. So then the main idea of metadata routing is that you have a top-level tool where you can pass your metadata into. In this case, it's cross-validate. So, and we pass our metadata as a dictionary called params. So we've passed it, and now the last step is that we have to define where we actually want to use the metadata in the end. So in order to do this, we have to set requests. Those are called set method requests, where you can exchange method by the actual method name. I will show you. So this is how it looks like. So we know that rich.fit can consume sample weight or use sample weight. So we set a set fit request on rich and say, yep, please use sample weight. Okay, and we also know that our scorer can use sample weights, so we set a score request and tell it directly, please use sample weight here. Because we might not want to use it there, because right now it's very flexible and you could set to use it or not to use it. And we remember that our group k-fold splitter uses groups on default, and we couldn't switch this functionality off, so the set split request is set by default, so we don't need to set it here. All right, so since we've done all of these 3 steps, we've enabled the metadata routing, we have passed the metadata to the top level tool, and then we've set all the requests. So we have, voila, a routing success, and everything works. All right. So the metadata routing API is almost fully available in the current newest version 1.5, and we expect it to be fully compatible in the next release, which is probably going to be released in November. And we are currently working on defining good defaults to relieve users from needing to set all the requests. So in future, you will have usable defaults, but we will still keep the flexibility in case you need it for your custom scenarios. All right, and with that, I give the voice to Guillaume, who will introduce you to one use case of metadata routing.
Thanks. So yeah, I'm speaking a bit loud. So I will introduce one case where metadata is kind of key because we couldn't do that before, in scikit-learn, and together with a new estimators that was released in the last release of scikit-learn that allowed to make optimal operational decisions. So first, what's the difference between classification and decisions? And probably you should stay in this room because there's a nice keynote by Olivier Gruzel that will speak a lot about those. But in short, if I take one example, which is like the credit card, the fraud detections in credit card transactions. If I'm a data scientist, I will try to train a classifiers, and what I would expect from that classifier is to give two type of outcome, one that is a legitimate transaction or fraudulent transactions. But if I'm a stakeholder or a business owner, what I would expect is a bit more than just that. So I could have a one-to-one correspondence between the legitimate and whether or not I should accept or not the transactions. But I could as well use metadata like the transactions. So for instance, if I have very, very high amount of transactions, maybe I don't want to process it automatically, okay? And I can take another decisions. So it shows that we have the classification part, one part with decisions, and then metadata can play in the middle to go from classifiers to decision maker in some way. And it comes as well on how do we evaluate those. So a classifier can use usual classification metrics, so like precision or recall or whatever, or true proper scoring rules if you are interested about the probabilities. And on the other side, when you want to evaluate operational decisions, you might be interested about the business metrics, so a utility function that will give you, if you are business, like in euros, what you are gaining or losing, okay? So let's go into the example that we implemented in scikit-learn that is about credit card fraud detections. So if I have some data and every row is actually a transactions, I have as well a metadata that will tell me what is the amount for each of the rows. And with those, I have the target that my classifier is supposed to do, so legitimate or fraudulent or 0 and 1 in that case. If I want to evaluate my classifiers, then I can go through the confusion matrix and, for instance, compute some metrics linked to that. But if I want a utility function, so business metrics, I need to translate every entry and observation from that contribute to this confusion matrix into a metric with euros or dollars, okay? So here I could go to my business analyst and ask him, okay, what would be the cost for those observations? And he could come back with a cost matrix where I could just combine those things together and come with a utility function that, for instance, here is just a multiplication of every entry and every observations and make the sum of those. So if I want to write Python codes that look like that, I will get a very hopeful function that looks like this one. And here, I don't really care about what is in the middle. What I care now is, because we speak a bit about API, is more about the signature of the functions. So I have the usual suspect, which is the true label and the prediction of the classifiers. But I have these new parameters, which is the amount that I need to compute my utility functions. But that is not unusual parameters. And is where I can just use what Stephanie just presented. So enable metadata routings and build a scorer. And the scorer is just to transform basically this function into an object that I can use afterwards inside estimator in scikit-learn or cross-validations. And from there, I just pass the function and explain to the classifier that I will call the predict method just to get the predictions. And in addition, I say that I will need you to request the amount variables whenever people call you, okay? So how do I use this in practice? That will look something like this. So I can train a classifier, for instance, that here is logistic regressions. And I can use this metric where I pass my classifier, the testing data, and this new amount test that allow me to compute my utility function, which is here in euros. And for instance, we can know what is the benefit loss of that specific classifier. However, so that's good. So that's already one part of how can I use metadata, but is in line with what Stephanie just said. But I'm still not, so I still have a classifier. So for instance, here I have a classifier. I can compute the ROC curve. And if I use that classifier in productions, my predict and the decision that he will give me, if it's fraudulent or legitimate, will be a cutoff point as 0.5 that corresponds to the 50% probabilities. But it doesn't mean that this is actually the optimum decisions, because I didn't input my business score. I didn't try to optimize my classifier for that. So this is where, and this is close to my heart, that we just implemented this new TunedThreshold classifier that can take a classifier, the business scores, and tune it, so calling fit with the three variables, and it will be able to find the optimum threshold, which is not anymore the default one at 50%. And that will lead to the maximum gain and to the maximum gain of my utility functions. Okay, and now I have just one operational decision makers, which is optimal for my programs. So this is to close more or less the new things about metadata and this decision making. So now I will go through a couple of other features that we got as well released in 1.5 or that are in process as well for 1.6 and afterwards. So first is interoperability of different type of data. So in the past, that's already a while, scikit-learn can just be fed with dataframe, pandas dataframe. And if I take, for instance, a scikit-learn transformer that looks like this, so here I have a column transformer where I process columns in different ways, whether they are categorical or numerical. In the very old time in scikit-learn, when you were calling, you were getting back a NumPy arrays. And a few versions ago, we introduced this set output functions method that allow you to say that at transform time, when you call transform, I would like to have a pandas data frame. Okay? So that's not new, but what we added in the latest release is that now if you put transform equal polars, then you can get a porous data frame. And if you can get a porous data frame as an output, you can as well input porous data frame in scikit-learn. Of course, this is really not optimal. This is inside scikit-learn itself, we are not dealing with porous data frame. Okay, so it is suboptimal in that way, in some regards, but we are able to consume them, convert them to NumPy, and then output back the type that you expect. we also have some new stuff regarding different type of arrays. So we are not dealing anymore with only NumPy arrays because we adopt something that is called the array API. So in short, the array API unlocks the possibility to make computations not on different type of hardware. So if I say different type of hardware, it's like if you have a GPU and that you have a torch tensor, then we will be able to keep the computation on the GPU and not bringing back the data on the CPU. So here I just give an example where on the left, I have just like some NumPy arrays, and on the right, I just move those arrays into the GPUs with some torch tensor. And then I will take a simple model, which is a PCA plus a ridge, okay, with very specific parameters, by the way. And the nice part is that by just adding one new line, which is a context manager here, and where I say user API, the same code will give the same results, which is already a good news. But more than that is something that was taking 40 seconds to work on the CPU is now taking 440 milliseconds on the GPU. Okay, so we have a huge accelerations. But if you are saying that's fine now, scikit-learn is very, very fast and work everywhere on GPUs, that's not the case. It's an ongoing work, so we have a very limited amount of estimator that have been implemented in scikit-learn. So in 1.5, we have this issue where we are tracking the progress. So we have many more steps that work in 1.6. But we have as well some limitations because not all the part of scikit-learn can be compatible because we have some Cython code, and then we cannot adopt the array API for those things. So this is a work in progress, but we already see that we have a couple of things that are working pretty well. Finally, we have some improvements regarding categorical and missing value support in tree-based models. So let's take like a very typical Titanic data set where I have missing data, like the non-null data that we see here, and some data which are categories, which is pandas category, or if you are in Pandas, we will have the categorical d-types as well. So in the past, with random forest, you needed to take care yourself about like numerical with missing values, for instance, in that case, like the numerical transformers. And you needed to like impute yourself with a strategy. Nowadays, you don't need anymore to do that. You can just pass through the missing values, and the random forest will take care about it. But we don't have anything about categorical here. You still need to encode them and to make a column transformer and to have some kind of burning plate code. However, in the histogram gradient boosting, which is like one of the additions that we have, in the past you needed exactly to do the same things. But in the new and the latest versions, because we handle missing values and use a categorical d-type from pandas, you just need to change all the code and just having that new parameters, categorical features from d-type, and it will detect which columns are categorical and then handle it as well naively inside. Not naively, natively. And on this, I'm concluding. So every code that we show here will be available soonish. I didn't have time to put everything and with Stephanie. But it will be available inside that repository on GitHub if you want some examples. I mean, there's already a couple of stuff there. Thank you.
We have a bit of time for questions. Okay, one person up there.
All right, cool, thanks. So for the GPU support, please stand up, sure thing. All right, let's do this. So for the GPU support, from what I remember, the array API compat package was being used, but it wasn't a required dependency. I'm just curious if you could say something about that, like will it become required? Do you vendor it?
So it is. I need to install it, at least for my example. So I assume that at the time that you turn to true, then you need to install the array API compat package.
Sure, but as in, if I just do pip install scikit-learn, then I don't get the array API compat package with that?
Sorry, I didn't get.
If I just do a plain pip install scikit-learn, I don't get array API compat.
No. Yeah, it's an optional dependency. So we raise you an errors at the moment that you start to use it. We tell you, oh, you missed that package. You need to install it. But why we don't? Is not inside the metadata of the Py project. Let's
Sure.
say.
But would you consider making it required just for a more streamlined experience for GPU users?
You have to speak with the stakeholder that implement that. I don't have strong opinions, but okay, one stakeholder is coming.
So I can answer this question. So the array API, since it's not implemented everywhere in scikit-learn, it's a bit like the routing API, the metadata routing API. Both are optional behavior that are not enabled by default. So you need to change your code to enable them. And once you enable them, in particular, once you enable the array API, then you need the extra dependency. But if you use the default scikit-learn, it's behaving the way it was behaving previously. Like, for instance, if you feed a torch tensor as an input, it will convert to NumPy array by default. That's the past behavior, and we still have this as a default behavior as long as we do not have an extensive support for the array API in many estimators. It's going to take a few more releases, I think. So in the future, once we have implemented the array API in many places of scikit-learn, almost everywhere, then we might consider switch it on by default. And maybe by that time, the array API compat module will not be needed anymore, hopefully. I'm not so sure. We might consider it, making it a dependency once we enable it by default. But as long as it's not enabled by default, we don't want to introduce a new dependency.
Thank you.
Any other question? Well, I have a question. It's also about the array API, so if you...
There is one minute.
Thank you for this talk. In fact, I have a question for the first talk about metadata routing. You give an example with men and women, and so I wonder if you are going to use that to implement fairness metrics, for instance.
Sorry, and what?
You are going to use such a feature to implement fairness metrics when you are a sensitive subgroup in a dataset.
You could do that, but we don't plan to do it in scikit-learn.
But the package fairlearn will use that. Okay, so we have people as well contributing to fairlearn, and basically we need, okay, you can come and speak.
So one of the main motivations of this whole metadata routing was that some of us were working on fairlearn that implements a lot of those metrics. That exists, and this already enables you to use a bunch of estimators from fairlearn as well as using the metrics. However, as fairlearn maintainers, we also extremely, we ask people to be very cautious to use single metrics to assess fairness of any models. You should probably look at multiple angles of your model before deciding whether or not something is fair. We do plan to have tutorials on the scikit-learn side and examples on how to deal with the fairness issues of your models, but it will all be depending on external packages. At least for now, we don't plan to include anything in the main library.
Is there any other core scikit-learn developer who wants to be on stage?
If you have a new question, yes.
Is there another question? Yes.
Thank you for the presentation. If I remember well, not so long ago, there was a formulary for people to give ideas on how scikit-learn could evolve. And I was wondering if you have also, in terms of priorities, a roadmap or where you should go, just to understand.
Yeah, so regarding roadmap, so we have a couple of things. So first, right now so if you go on the website of scikit-learn, you have a survey, a user survey that is happening, so you can answer to it. And that thing is helping us as well to know because we have a roadmap on the website as well, but it's old, and we are on the way to update it. In the meanwhile, on Probable website, we have a blog post on what are the priority of like the core teams from scikit-learn that work at Probables on which things we are working, part of this bigger roadmap. But basically, there will be like one document on the community website and one document at Probable that say which of the features that are on the community we are focusing on. So there's like those 2 entry points, let's say. But this is going to be updated as well when we have more information from users through the survey, because we want to know what people need. Okay, so that's.
So we've reached the hour, unfortunately. So if you have more questions for scikit-learn developers, you can recognize them. They have really nice Probable hoodies. So thanks, everyone. Please give them a round of applause.